Hello everyone, welcome back to the one more session of multimedia systems. We were discussing about the topic called the data compression. Let us continue our discussion with the same topic of data compression. Let us recall what we had discussed in the previous session. In the previous session, we had discussed about the zero suppression algorithm, vector quantization, pattern substitution, diatomic encoding, statistical coding, and also the Huffman coding with the illustration taking a suitable example. These topics were discussed in the previous session. Let us continue our discussion with the next topic. So in the next topic, let us discuss about the topic called the arithmetic coding. As you know, so this is one more category of algorithm like the run length and the Huffman coding. So like Huffman coding, it is optimal from an informational theoretical point of view. Therefore, the length of the coded data is also very much minimal in this coding algorithm. Arithmetic coding does not code any symbol separately. Thus, a data stream encoded in this form or a fashion must always be read from the beginning. This is the key point with respect to the arithmetic coding and the other coding technique. Consequently, random access is not possible here because we need to be reading from a beginning till the end in a continuous stretch. So random access of coding or fetching of data intermediately is not possible. So average compression ratio achieved by the arithmetic coding and the Huffman coding is almost similar. We can also say it identical or a similar fashion. And also the percentage in the Huffman we had received a very good percentage, and even the arithmetic coding also be able to achieve the same rate of compression. It is best suited than Huffman coding in the digitized graphic. Means this arithmetic coding is very much suited for the digitized graphic consisting of primarily a single color, means a common background color. So this kind of coding is best suited for the graphical images. This is the key point with respect to the arithmetic coding. Let us look into some of the other basic techniques that are available or achievable. When I talk about other basic techniques, apart from the compression techniques which has been described earlier so far in some of the session, some additional well-known techniques are also used in today's day-to-day activities. Video compression techniques often use the color lookup table. So this is very important. Color lookup table. The best example to illustrate what you mean by color lookup table is, you might have seen an artist or a paint use as a palette. So in the palette, the places for the color deposition is identified with a number and particular color will be there. So whenever an artist wanted to use a particular color, he looks into its palette with the places provided, he picks up this color with a brush and start painting it. In the similar way, the color lookup table is a table which constitutes a value of an attribute or a pixel that has been encoded with the image. So this kind of representation of the value of a pixel in a table form is said to be a color lookup table. This technique is used in distributed multimedia systems. When I talk about distributed media, try to recall the session 2 of a module 1 where we have clearly discussed what is the media, how is distributed media are there, what are the different kinds of multimedia, everything has been discussed. And a simple technique for audio is silence suppression. So this is very important. So when you talk about the silence suppression, because when there is no data in audio itself, so it goes on and some amount of data is also being used just to store a silence. So if we reduce those silence, means there is no data except the silence, we reduce it, then the storage of that audio is also reduced. So in audio, what do we need to separate? The silence is a thing that needs to be compressed, whereby data is only encoded if a value exceeds a certain threshold. Means, when you talk about the video, you know that what we compress it. When you talk about the audio, it is the silence suppression. What we compress or what we encode, only the data that is present in the data stream, that is with respect to audio, is compressed, whereas are encoded, whereas the silence is totally compressed because there is no data except silence. These are the different kinds of techniques that has been used in day-to-day life with respect to some of the basic techniques. Now let us look into one of the predominant feature of a image compression, that is JPEG. Very important aspect when you talk about any image or a compression technique. So what does a JPEG abbreviate mean? It is Joint Photographics Expert Group. So the abbreviation of JPEG is, I'll repeat it again, Joint Photographics Experts Group. So since June 1982, a working group, it was called WG8, means Working Group 8 of ISO has been working on the standards for the compression and decompression of still images, because till then in 1982 till 1982 there was no particular standards, predefined standards of still images. So this group, that group was constituted by many professionals and technical persons, and they called their group as WG8, means Working Group 8. Sorry. And they were working on the techniques or bring out the particular standard with respect to the compression and decompression with respect to a still image. So in June, they started it in 1982. What happened in 1987? So from here to here, what happened? 10 different techniques for coding of color and also gray scale was done. Gray and color, 10 techniques. This Working Group 8 came out with 10 different kinds of compression and decompression technique with respect to a still images of color and also grayscale images, and they took around till the year 1987. So along with the 10 techniques, also some other techniques that was prevailed in those period of time was also considered. But among these techniques, the discrete cosine transformation, what is that? We call it as DCT. Very important. So it is abbreviated as discrete cosine transformation, was the only technique which was able to achieve the best results. Means from 82 to 87, they invested their knowledge and time in order to bring a new standard or a technique for the still images with respect to gray and the color. But 10 plus standards, but at 1987 they came out with the DCT, that is discrete cosine transformation, was the best to achieve the results among all the 10 plus techniques. In 1992, remember, it took almost 10 years of work. In 1992, JPEG became the international standard. Means they did not just say it, this technique is better, so we'll make it an international standard. They had a lot of research, lot of work was done, analysis was done, comparative study was done with respect to many of the other techniques with respect to a compression and also decompression. Later, only in 1992, they came up to say that JPEG is an international standard. JPEG applies for both color and grayscale image. This is very important. It is not suited for only grayscale or a color. It is very much well suited for the color and grayscale images. Video sequence can also be handled through the fast coding and decoding of still image, and the technique is also known as MPEG or MJPG, that is motion JPEG. Means they are mainly concentrated on the still images, but still the compression of these images with respect to a bit of motion was also achieved, and they called it as motion JPEG. This was a brief history about the JPEG and it became how it became a standardized. So let us continue our discussion with the JPEG itself. Now you know when was the JPEG came into picture and why did it came into picture and what kind of technique it was used and how it became a standard. Out of 10 plus techniques, JPEG was considered, DCT was considered the best technique, and they use it in a JPEG format and they made it as an international standard. Now the suitable compression is said to be a JPEG format. Why it is said to be suitable? You might be seeing many of the cameras, digital cameras till now uses JPEG as their standard format. There are n number of image formats with respect to still images, but still JPEG has been used as a standardized format. It might be a Canon, Nikon, Pentax or any kind of camera standard, international camera standards. They use JPEG as the standard. Why? This is the important, because it is suitable for what? Compression and decompression. This is important, and even I will tell you why camera companies are using it for a till now, why it is made it as a default, and it is the first international standard, okay, for image compression. This technique became the first standards with respect to the image compression. That's why this image of JPEG is been used by many of the digital devices, and also it supports, how much it supports the color, 2 to the power of 24 colors. You might be knowing there are many other image formats which uses lesser than this value, that is 2 to the power of 24 colors are supported by JPEG, and it helps in various levels of compression. This is very important. There are few limitations with respect to compression with respect to other image format, whereas JPEG supports the different and various levels of a data compression. We'll discuss when we come to the JPEG mode of compression all these things, and it is a lossy compression technique. That is important thing. It is a lossy compression. What do we mean by lossy? Some of the little bit or some portion of the information is lost during the process of compression and decompression. So when we talk about the lossy, you know that not everything is lost. A bit of information is lost which would not harm or have a greater impact with respect to the originality. So that is called a lossy, and this technique, though it uses lossy technique, image resolution remains high. This is very important. Image resolution. This is why I said you most of the digital cameras even till today uses the JPEG as their default standard. So what is this? Image resolution remains high even after compression. Means, what do you mean by that? When you talk about the process of compression, the compression happens with a lossy technique. So when you decompress it, when you say about the compression during the quantization, some of the information is lost and the original image quality has been altered. When you decompress it or retrieve that information, that quantized information, that few of information that's been lost is not able to achieve it, but we are able to get the image, identify the image, but some of the qualities has been lost, but the resolution is not spoiled. Whereas in other basic techniques or other image format, this resolution will also be altered. Whereas in a JPEG, the resolution remains high. That's why in most of the cameras, when they talk about the digital devices, the still images, still they use JPEG as their default standard. So this was about a brief introduction with respect to JPEG history, why JPEG is being used, why it has become a very good standard, and why people are referring or still people prefer to use JPEG as their default standard. Now let us look into the modes. Now let us see the modes of a JPEG. So JPEG defines 4 modes themselves. It includes additional variations also, but in standard it has 4 modes. 4 modes are mainly supported. The first one is Lossy Sequential DCT mode. Lossy Sequential DCT-based mode. So what does it happens? Here it uses baseline process or base mode. So in this technique, as the name itself suggests, lossy. So I will define what is meant by lossy, lossless, and the progressive and also hybrid, hierarchical and everything later. So in the lossy sequential basic DCT mode, here all the JPEGs use DCT, that is discrete cosine transformation, for the compression technique, and the basic operation is done with respect to sequentiality here. So when you do up a sequentiality of compression with respect to lossy, then this mode few amount of information is lost. So it is very much supported by every JPEG decoder. This technique is always a default one with respect to any of the compression and the decoder of a JPEG standard. Second one, see, first one is a lossy sequential and the second one is a expanded lossy DCT-based mode. So what do we do here? It is slightly an improved version of a lossy. Okay, here it provides a set of further enhancement with respect to the base mode. That's it. A slight improvement with respect to the lossy sequential is said to be a expanded lossy, where some of the features has been added. Third one is lossless mode. As the name suggests, loss very much less. Though this kind of JPEG comes under the lossy mode, here in the talk about lossless mode, here the loss of information is very low. Means the data that is lost is very negligible. So has a low compression ratio. So whereas here we achieve high compression, in the lossless mode we achieve very low compression ratio and allows perfect reconstruction of the original image. Means the compression ratio achieved is very less, and when we try to regain, it is also able to get the original image because nothing is lost. or negligible amount of information is lost. When every coefficients are available, it is easy to reconstruct back to the original image. That is called the lossless mode. And finally, the fourth one, hierarchical mode. So what is hierarchical mode? It is accomplished, or it can accommodate the images of different resolution by using the algorithm that been defined in the 3 modes. Means the different algorithms used in the above 3 modes can be combined together, will accomplish the hierarchical mode. So JPEG, when we talk about JPEG, we have 4 modes. First one is a lossy sequential DCT mode, which uses the baseline process or the base mode, which supports every JPEG decoder. Second one is an expanded lossy DCT mode, which provides a further enhancement, a set of further enhancement, a bit better than the original lossy. Okay, and third one is lossless mode, because here the information lost is very less, so we have very low compression rate and allows the perfect reconstruction of the original image. Means the original image is obtained back with all the coefficients with respect to a standard. And finally, we have hierarchical mode, which can be accommodating with respect to various resolutions. So this algorithm suppose, or technique mode suppose, the algorithms that have been used in all the above 3 modes can be combined in various combinations, and this hierarchical mode is achieved. This was about the JPEG modes. And when we talk about the sequential, the progressive, and also with respect to hybrid, I'll talk about those things. So because what do you mean by sequential, progressive, these things to be understand. First, we'll look into the sequential. So these are the 3 different methods of reconstructing the image. So when it is compressed, when we try to reconstruct, there are 3 methods. One is a sequential method. So what is the difference between sequential, progressive, and hybrid? Okay. When we talk about the sequential things, if this is a frame, you might have seen the still image will be in a sequence, or it will be generated in a sequential. Suppose if the image consists of a face of a person, okay, the first sequentially generates. First the hair will be coming up, and next the forehead, next eyes. So a portion, if consider this is the original image, eyebrows, eyes, nose, and a mouth. If the consider for just an illustration, this is the image. In a sequential mode, what happens? In a sequence order from the top down, the first this part is constructed or visible, and next it goes off like this, where eyebrows come up, next the eyes come up, next the nose, and next the mouth, and then the image is converted. So what about in a progressive way? In a progressive way, you might have seen the image is generated, but it is totally blur. Okay, we are able to see a particular image and recognize it is the face of someone, but you are not able to see whose face is it, or you are not able to recall or recognize a particular person's face. Over a period of time, progressively, after repeated scanning, a clear image is constructed. Okay, so you might, this kind of things can be encountered when you try to download a image, very high resolution image, sometimes from your email or from a net. You might have seen when you click up download and try to open it, the image, the forehead comes up, next till eyes comes up, till the nose comes up, and then chin, and next the cheeks and the neck, and finally you get a complete image. But though you get the eyes and the nose till part, it is very clearly visible because it is a sequential mode. Here nothing is visible because it is the image is created in a sequential mode, that is called a sequential progression. And here in a progressive way, a complete picture of an image or face has been done or generated, but it is not at all clear. So it is totally blurred with a progressive interleaved scanning. So after a period of time, or it is in a milliseconds, you will be able to make the image recognize, oh, it looks something like this position, and again after some milliseconds the image quality enhances, and finally you get a very good image. So that is about a progressive, and hybrid is a combination of these two, is said to be a hybrid. So that's why this kind of terminologies will be used in this chapter, so it should be very clear. Next, let us look into the steps of JPEG compression techniques. So we have seen the four modes. Let us see or discuss with respect to JPEG compression. So this is very much represented with a diagram. The first diagram, it says, first step, picture preparation. When you talk about the picture preparation, we need to make the image ready because all the images will not be digitized. So in a JPEG, first if you want to compress it or do a process, we want to make the input ready into a digitized form, so that it should be in a pixel form. What is that and everything we'll discuss in the upcoming topic, pixel, and it would be using blocks and MOUs. So once the image is ready, next we'll go with the next step, that is called picture processing. So what we do here in the picture processing, we have a predictor. And also we use DCT. So what is predictor and DCT? We'll get to know. So once when picture preparation is ready and processing is done of image into a required format, then actually what we do is a compression. We call it as quantization. Quantization is the actual process where we reduce the size of an image. Okay, so here the picture is made ready for the activity, that is input is made ready, and here the processing is done with respect to predator, and we apply the algorithms and other things. When it is ready, when applying, we get a quantization process where exactly we reduce the size of an image. And finally we have, is it visible here? Yes. We have entropy coding. So when we have an entropy coding here, we can use the basic three kinds of algorithms what we have discussed, that is run length, Huffman, and arithmetic. and finally we get a compressed image. So this is the basic step of a JPEG compression technique, or we can call it as a summary of a different compression modes of a JPEG image. So this is the important thing that needs to be considered. Next, in some of the examination papers they were asked, explain the various JPEG modes along with the compression standard or a summary that has been deployed with respect to JPEG. In those cases you are supposed to explain the JPEG mode, and this diagram is required with the explanation. Next we look into the expanded lossy. Expanded lossy DCT based mode. It is the method JPEG specifies a progressive encoding in addition to sequential coding in the first run itself. That's why instead of going with these things, I explained about the sequential, progressive and also hybrid techniques. So in this method what happens, it specifies, JPEG specifies progressive kind of encoding in addition to the sequential coding in the first run itself. A very rough presentation of an image will appear, means the image will appear, it would be very rough, means you are able to identify or recognize it's a face of a person, but you will be not able to identify who is that person because the image is so rough, which looks like a out of focus. Means whenever you try to focus a particular person in a camera, and when it is out of focus, you will be able to see the outline structure of a person, that is a face, and the clear contents of the eyes, nose and face are not visible because it is out of focus. That kind of image is produced initially with respect to expanded lossy or in a progressive techniques. Out of focus, and it is refined, means this algorithm repeats until the progressive way to find an optimal or beautiful image is generated. Progressive image representation is achieved by an expansion of quantization. It is called layered coding. Means you know that I explained you in a progressive image, the first the raw picture is very rough and the quantization is very high, and the layered coding is done repeatedly in a progressive way. So when you have progressive way of approach, the quality of image is enhanced. So for the first step it was raw, second step a little better, third step much more better, and the number of progression depends on the quantization you require. So this kind of technique is said to be the lossy, expanded lossy DCT based mode. Next we look into the lossless mode. When we talk about the lossless mode, the decoder renders an exact reproduction of a original digital image. Means in this, whereas in all the other mode there is a difference with respect to the image created after a decompression and the original image, whereas here in the lossless mode the decoder, that is the after compression, the decompression process, the technique or the method that's been used after the decoder renders exact reproduction. Means it can produce an exact image which is like a original digital image itself. This mode uses data units of single pixels for image preparation, and any precision between 2 to 16 per pixel can be used. Means here 2 to 16 pixel precision can be used, because when you have 2 to 16 pixel precision, if there is anything, any pixel or any 1 or 2 pixel loss, it is not at all a problem. You can predict the other things and regain the back. Suppose if you consider the palm, okay, this is the image, okay, you get everything and bit of portion of this color is lost. It is very easy. or a prediction can be made, the portion of the hand here where color is lost will be almost similar to the adjacent cell. So this kind of prediction can be done, and the color can be borrowed from the neighboring cells and assume it to be the color, and it always achieves to be an exact replication. So image processing and quantization use a predictive technique instead of transformation encoding technique, whereas the other technique is totally using a transformation, means image is transformed to another form. Here the image is constructed with the prediction kind of technique. We will see with the help of a diagram with respect to lossy mode itself. The first one, the input would be a blank, that is uncompressed digital data. So we are taking the uncompressed digital data. So it has to undergo the process. First one is prediction technique. First we have a prediction technique, and next we do a entropy encoder. This is a complete one process. What we do here, the first one is the uncompressed data, digital data is pushed into the next process. We call here it as predictive technique, where in the predictive technique what we do here, we create a table. Okay, we predict all the cases and we predict a table, and when we try to encode it into a new form, we use this predictive data along with the contents of the tables, which is fed as an input at this stage. And finally we get the compressed data, compressed digital data. So here what happens, there is no loss obtained because we are predicting the pixels and its values, and also there is a table, prediction table, that supports the value what has to be predicted, and that can be used with respect to reconstruction or with respect to the compression and decompression with the images. And when we decode it, it renders an exact reproduction of the original image. That's why here we don't find any kind of losses, or we are able to achieve exact replica of an original image. Let us consider an illustration now. Usually when we talk about the image, we always classify into 8 cross 8 pixels of matrix, and when we work on it. So consider we have the pixel value C, B and A, but we want to find the pixel value of this cell. So we call it as X. We don't know the value of X. So what we do, we are supposed to predict it. So we create a table here. So here we say about prediction technique is being used. So what is that prediction technique? So I'll rub this diagram and write this table here. The first one is the selection. So we can have n number of selections. So it depends. We can have 8, 16 and other things. It is totally left to the individual. And we have the predictions that we do. So here what we consider, I take about 8 predictions. For 0, for 1, for 2, for 3, for 4, for 5, for 6 and 7. Okay. So this prediction table is totally designed by us. Okay. So what we do? If the value is 0, no prediction. Means no value is there. Suppose if it is 1, we'll write x is equal to a. What is x? This cell. We are talking about this. The value of x is said to be a. If a is, what do you mean by a? It is the values of the neighboring cells like this. If the selection is 2, the x is equal to b. And if the selection is 3, and x is equal to c. And selection is 4, what we do? X is equal to a plus b plus c. So, sir, you might be asking, why do you take this? It's our choice. It is our prediction. It is said, what does the title say? Predictions. We are predicting it. You can have your own predictive formulas here. So when the case is 5, I write it as x is equal to a plus of b minus c by 2. Why is this? My prediction. Okay. When x is equal to 6, x is equal to b plus a minus c by 2. What about the last prediction? I can have my own. That is x is equal to a plus b whole thing divided by 2. So we have 8 selections. Out of 8 selections, we have predicted these values. So if the cell comes 1, 2, 3, 4, our prediction could be here, it would be x is equal to a plus b plus c, this value. So this is how we predict rather than leaving off the things or discarding the pixel value. What happens if we discard? If we discard, a loss of information happens. Whereas here, we are not discarding anything. We are predicting the values and ascertaining it to a particular thing. So then what we get? We get a complete value for each and every pixel. This is how in the lossy technique we don't lose, in a lossless thing we don't lose any kind of information. The original image, exact replica is constructed even after the decompression. So this is about the expanded and the lossy techniques. Now we'll look into the exact thing of the core part of JPEG. Now we'll start with the things. What is that? We'll see how JPEG compression works. This is the core part which everyone is looking forward, or even in the exams with respect to video final exams, they ask this. Explain the JPEG compression working principle. Now, the total JPEG compression technique can be categorized or divided into 7 steps. Let us see what are those. First one is said to be splitting. So what we do here in the splitting, here the image is first one prepared, that is digitized, then image is split into 8 cross 8 non-overlapping blocks. Means 8 into 8 non-overlapping blocks. What do you mean by this? Sir, what do you mean by splitting of the image? Yes. Now consider this is the image what you have. In that you have an image where you have a character called A. Now you are supposed to split this image into 8 cross 8. So this image after splitting looks like this. One, two, three, 4, 5, 6, 7 and 8. Similarly, equally 1, 2, 3, 4, 5, 6, 7 and 8. Now I have an 8 cross 8 block, and if we try to replicate here, it would come up something like this. For the consideration to be made. Okay, this is called the preparation of an image. Next, in the second step, the color space transformation has to be done. What is that? What we do here? Color space transformation. What we do here? Here we are converting, we know that most of the image will be in RGB format, that is red, green and a blue format. We are supposed to convert this image from RGB format to YUV or YIQ format. So we know that YUV means what, YIQ means what. So what means Y means the luminance. Luminance factor, when you call about luminance, it is brightness. Okay, UV means the chrominance. Chrominance means the color factor. There are two kinds of patterns or a technique, YUV format or YIQ, even it's same. We here Y means luminance, IQ means the chrominance factor. We need to transform the image from the RGB to YUV or YIQ format. So Y means to have a clear separation. Next, we will be applying in the third stage the DCT. What is DCT? Discrete cosine transformation, because we know that we in the previous slides and previous discussion we saw that it is the best method that is been adopted out of 10 plus techniques. So JPEG is supporting DCT. Now we apply the DCT technique on this 8 cross 8 block. So now the 8 cross 8 block has been generated and the RGB to YUV format is done. Now we apply DCT. Now after applying DCT, what happens? We are using the quantization method. So here quantization means here we quantize with respect to DCT coefficient. Exact loss of information is happening at this stage. Why is this information loss happening? Because we are compressing the image. So we are leaving the other components which are not much necessary and retain the remaining things, and we are compressing. That's why during the process of quantization we lose some amount of information. And the fifth one is serialization. Here the interesting step of a JPEG is done, that is zigzag scanning. You might have seen with respect to JPEG, zigzag kind of scanning. That kind of scanning is done here on the DC components of the image that's been done. And finally, after the zigzag scanning, we do vectoring. What is vectoring? Here we apply the differential PCM on the DC component. What is PCM? Pulse code modulation. We apply the values of the differential PCM on the DC components. That is called vectorization or vectoring. Finally, what we do? We apply the algorithms. It might be a run length or it might be a Huffman coding algorithm. So these are the steps to compress an image in a JPEG format. So now we have seen the working or how JPEG compression works. In the next class we will see with an example how this JPEG completely works. So before winding up this session, I would like to recall or summarize this session. In this session, we had discussed about the arithmetic coding, other basic techniques that are associated with the compression. We have seen what do you mean by JPEG, history, and how JPEG became an international standard, and it was also called the first standard. And we have seen the 4 modes of the JPEG and also the summarization picture of JPEG compression with respect to the 4 modes. We have seen expanded lossy DCT mode, lossy mode, and finally we have discussed about the various compression steps that are associated with the working of the JPEG compression. These are the things I had wished to discuss in this session. Thank you very much.